What we're kind of talking about, because that was the following off of micro LED, another company making a bit of a splash there was TCL. TCL, I did not get to see this. I should have signed up on day one. I didn't have high expectations for it. I have heard reports that it did what I expected it would do. I've worked with it. Basically, what they're doing, it's a color micro LED. They're using Jaybird displays, as far as I'm aware. And this is a picture I took from Jaybird. On the lower right corner is a picture I took with Jaybird display. I took it at the AR VR MR 2022 that we talked about. I think we talked about this some. I think I mentioned in that video that I'm pretty skeptical of the problems with doing a small cube. I actually worked with larger cubes doing front projectors back in the early part of the decade, about around 2005 or 6, or 2004 or 5. I was working with these bigger versions. The problem you have, and you might be able to see it in this thing, is you'll see a little white line going through here. The problem is this is actually made of 4 prisms, labeled 1, 2, 3, and 4 here. You then glue them together. Each of those prism faces, each one of these guys' faces are actually 2 different coatings. So you have a dichroic coating on each one. There's no way to make a perfect cube. No matter how much you grind and whatnot, you can't make them perfect. And then when you fit them together, there's always a seam. Well, if you build a big cube, that seam is out of focus. As a little bit like we talked about with these, as you start to bring that cube, make that cube smaller and smaller and smaller, the seam becomes ever more significant and ever more in focus because it's closer. Basically, your panel is going to be sitting on one of these surfaces. Additionally, you have the problem that you now have to align 3 really tiny displays. Like in the good old days, literally these were done by hand. They never had a machine that could do it well enough. So they literally had a little jig on each one. Each one of those faces had a jig, and a person with a screwdriver would do it. And you always glue in optics. In optics, they never trust a screw. A screw's only for adjusting. When you get all done, you put glue on it, UV cure it. Something else that'll come up later today is UV. A lot of things in optics are UV cured glues. But anyway, so you've got this seam in the middle. This seam will cause problems. Aligning these things, and they have to be aligned with 6 degrees of freedom. Everyone thinks, oh, we'll just slap them on the faces and then we'll do it. It doesn't work like that in the real world. The faces are actually not perpendicular enough to each other to work. So you have to do an alignment thing. And you have to do that with 6 degrees of freedom. And everyone thinks, well, we'll just fix it up in digital. You can fix the up and wide. That's not the one that worries me anyway. The one that worries me is focus. If one of those is just a little bit crooked relative to the other ones, everything is out of focus. So generally, you get your green aligned through your optics. You have to wait till you build up your optics, align your green, then you align your red, then you align your blue, and you have to get everybody perfect with 6 degrees of freedom. It's a big job. It's a hard job. It's not the kind of thing you really want to do at a microscopic level. This is another big theme I have for going to shows, is that just because somebody has something in a show does not mean they're ready to go to production. What I heard, I did not see it, but I've had at least 2 reports that the image quality was pretty bad.
Mm-hmm. That's what I heard too.
There was one online picture seen through one. It looks, and I'm not quite sure what kind of waveguide they're using. It might be some kind of diffraction, but everyone's noticed how dark the first one is. I don't know if it's some kind of mirror reflector. I wasn't able to tell right off the bat what it was, but you can see there's a pretty dramatic where you can see a very dark area, and then there's 3 of these. These are doing pupil replication or of some kind, but there's 3 different shades of it. So it may not be a straight diffractive. It doesn't look diffractive. It looks more like something Lumus would do, but maybe not done as well.
I think one fun thing about these events too is like if something is actually like really cool to try out, especially on the show floor, and you're like really into the community and have like a lot of people that are there, they'll usually tell you what things like excite them. And no one said TCL, at least in my groups. I mean, it was hard to get in. I think with my media credentials, I could have gotten to see it. I had other things to do. I was too busy.
But they also had the bird bath. I call this yet another bird bath. I don't even think I talk much about bird baths. Really, it was ODG, Osterhaus Design Group, who's no longer with us as a company, but their people are spread to the four winds. So some of the designs you see are designed by former ODG people. As a matter of fact, even though they're used digital lenses using waveguides, at least one or two of their people are from ODG. So ODG spun out. But basically, this bird bath design is all copied. They're all look to me like ODG R9s. In spirit anyway. It's a simple bird bath with a curve combiner on the front. I see so many of these, I don't even consider them remarkable. There must be 20 of them out there now. There's companies in China who make the optics. You can get the OLEDs. The high-end ones will use Sony. Lower cost ones, there's I think a few Chinese suppliers.
Cia Tech is a big one for that.
What's that?
Cia Tech is a big one for that as well. Chinese company,
yeah. So one other comment here, though, the other way of combining, and I'm going to talk about Vuzix some more later. Vuzix had a fairly impressive thing with they built a small green one, but I haven't gotten an answer yet on what size micro LED. I think they may be using a smaller one because the ones I got to try on and I got pictures of are the bigger ones, the bigger glasses. I wasn't even thinking. I thought they were the smaller ones. You know, those things in the show, you're going bam, bam, bam. But anyway, one of the things they did in one of their videos was to go side by side. Instead of having a color cube, you have three waveguides, each spatially separated. That's one of the ways you can make a waveguide. Matter of fact, the original Magic Leap 1 was spatially separated. That's how they did the red, green, and blue went in different spots, and the two different waveguides were in different physical locations. So it's definitely possible to do this. You basically have the waveguide bring it in, and you have three illuminators. But now you got three sets of optics, and you got this big long bar. So you can imagine this little rectangle here now is 3 times as wide.
Yeah.
Each guy having their own optics. So that's a problem.
Vuzix is one of those companies where even when I was at the show, I kept getting random Twitter ads like, hey, do you check out Vuzix, blah, blah, blah. Just from like people, I think, trying to bump up the stock price all the time. They're one of those companies on my list.
Yeah, I don't know. No, I did not get a lot of that. By the way, I always joke, though, and I threw this Facebook patent in there. I said, if you can dream it, Facebook's tried it. And this was one of my truisms on it, because I ended up, after I saw this from them, I went up and dug up. I was actually able to find a Facebook patent showing the same concept. So it's kind of the way the world goes. But anyway, so I think this is a classic example of something you can demo that you can't make in production. I mean, you know, you can spend. Yeah, I can spend forever. If you told me I wanted to get something to market in a hurry with 3 chips, yeah, I could get you one to show it to you to a demo, but I'm not going to production like that. I don't believe, and maybe they'll prove me wrong. Maybe they'll come up with some miracle of engineering. There's also by the way, some optics problems too, because you've moved basically, if you see the panels are on the far side from the lens. These optics get a bit more complicated. Each of these optics is more complicated because it's farther away than you would like to be from the display. And so you have to make some more complicated optics in here. So if you compare this to like the Vuzix Green, this lens is a lot bigger. This lens setup here. And the Vuzix had an interesting demo. What I don't know is how much resolution it has and how good the image quality is and all, because I didn't see it. I did get to see the other one. Let's talk about AddOptics, and this will actually could be interesting to other people as well. You may remember we talked about Lux XL last time. Last time we met, there was a company called Lux XL. As you may know, they've now been bought by your favorite company, Meta. I say that sarcastically. It seems like every time we've matter of fact, that's how we started collaborating. We were talking about this one company because I'd said this company disappeared, and when I was looking for why they disappeared, I ran into you and you had talked about them. And then a couple of days later, I said I found out they'd been bought by Meta.
Yeah. It's we're the curse. We're doing it. It's us.
What's that? It's us. Yeah. I almost hate to say these are good things. Oops, I'm sorry. There's a
Yeah.
mistake down here. I'll talk about that in a minute. But anyway, so yeah, what AddOptics is doing is 3D printed molds. By the way, they're happen to be not very far away physically from there, and I think some of the people from Lux XL are at AddOptics. The basic idea is Lux XL was very simple concept, 3D printing. They're literally printing the optics. The problem you have is when you print, you may have to compromise on the properties of the printing material to make it, because it's got to be optically clear. It's got to freeze really quickly because you're printing extremely fine layers. It has to be extremely thin. So you may give up on other properties that you desire to get that. So one could argue that Lux XL was great for prototyping. The other problem is it's probably not the best thing for production because each one requires a great big machine to print one set of optics.
Yeah.
So you print one lens. So it's very good for customization, very good for prototyping. The question is it good for production if you're going to make it? Because now each one requires a big machine to make it. The other problem you have is the physical properties, I should say, of the printing material may not be the best. For example, I've heard from several sources that Lux XL yellows. So when you get it out in UV light, out on the outside, it may turn yellow.
Right.
And maybe they'll probably work on it. They may fix it. The other problem, though, that they may never fix is that it's birefringent. And what that means is when light, if you take polarized light through it, it will affect the polarization. So if you use it in any kind of polarizing optics, let's see, pancake optics.
Yeah, I was about to say.
If you use it with you cannot use it in pancake optics because if you try to build a lens with that, now maybe you could build it on the outer surfaces if the light, but if there's any polarized light involved, what's going to happen is it's going to turn into an analyzer, and you'll see, or a strain gauge. You will see you've seen these things where you get these rainbow of colors when you take polarized light through layers of cellophane tape and all. What that is that's birefringence. That's the light is manipulating it. When you put polarized light in between, when you run polarized light through a birefringent material, it means it's going to variably change the polarization of the light in ways you don't like. It's also a problem with injection molding. One thing that AddOptics does that's different is whereas the 3D, they're printing, by the way, to be clear, what AddOptics does is prints a mold. So they're doing 3D printing of a mold, not of the optics themselves.
Right.
So it's a little bit like, people will sometimes do this. They'll 3D print something and then use the 3D print to make a mold when they want to make copies, because maybe they want to make the molded metal. And there's no unless you got one of those really high-end machines, you could make a mold that could withstand. You take the device, then make a mold, then copy that mold in a material that you couldn't print. So what AddOptics does is they are using a UV cured resin, UV cured plastic, but what they're doing is they're doing it what they do is they're using different plastics. They can use plastics that don't have to cure so fast. I think they say it can take several days for theirs to cure. Because it cures slowly, they can avoid birefringent. They can use chemicals and they can use formulas of basically resins that are not not inherently birefringent. They cure in ways that don't cause polarization problems. And they can use materials that are more UV stable, so they don't yellow and stuff. So they have a material an advantage. The other advantage I see them having is if you want to stamp out a lot of these, you can make a mold, and then they say, hey, the mold is relatively cheap. You're only tying up a mold, so you can now replicate that mold. They think they can get about 100 copies per mold, because eventually molds, these are somewhat soft molds.
Yeah.
So that they're going to eventually just get destroyed. They're not like a hard mold. But this does mean this is really a good in between for, like, if you wanted to prototype, it's not that ridiculous to make a mold. You could print one. and then you can make a few copies of your thing versus having to start from scratch each time. What I don't know is what happens if you went for like prescription optics, because one of the big things for Lux XL is, in theory, you could program in the prescription, and when you're all done, you get a prescription optic. In theory, you'd have to make a new mold for each prescription. Now, if you're talking simple optics, not Verilux or varifocal lenses, Verilux is a brand name, the varifocal type, there's about 400 common combinations. If you look at both astigmatism and diopter, this is one of the problems you have with all these other guys. A lot of these guys talk about having diopter adjustment, like the
Vive
HTC demo has diopter adjustments, doesn't do anything for astigmatism.
Right.
I have really bad astigmatism. I don't have much in the way of diopter. I'm like a -1 diopter, which is kind of minimal. But I have really bad astigmatism, which is kind of like a barrel distortion. They sometimes call it well, basically it's a barrel, a rounded distortion, or as opposed to, or cylindrical. That's the word, cylindrical distortion, as opposed to a distortion in the other direction. So generally, if you want to cover all the common astigmatisms and all the common diopters, you need about 400 lenses. And that's one of the ways you can do 1 hour lens service. You can, all they're doing is cutting. They take a lens blank, cut it, put it in the lens. That's all you got to do.
Yeah.
But if you want to start dealing with varifocal, then you've got to now start grinding. Almost, I think today on a modern optics you buy, they do have to grind them. I don't know whether their lenses are grindable, so they can be done for that. Of course, you might argue, do you really want to do that? You certainly want to do that in VR. You don't need varifocal. The focus distance is always the same, so it's not as important in some markets. But anyway, this optics could be really interesting to you could imagine, to the VR world, and very interesting to people wanting to do maybe a variable pancake, say a pancakes with some optics built into it. So anyway, it's an interesting company, made more interesting by the fact that Lux XL is now part of Meta. Another one we talked about last time, so I'll just throw this up here real quickly. This was meant to be on a different slide, but I didn't delete this one. But there's as a matter of fact, let's go to that. So that the Metamaterials, that same company that did the dimming technology, as we talked last time, and this is taken right from our last discussion. Metamaterials also has another process where they use glass molds, and I believe they can even munch these around a little bit to deal with astigmatism. But basically, what they do is they take 2 glass molds. They can also embed their materials, like they have these metamaterials they can embed in between. I think that's the reason why they bought this company called Interglass. They bought them so they could put films and stuff in there. I know, and I don't know all the history and stuff, but I know that Tobai, we've talked about with them with eye tracking. Tobai was working with Interglass. I don't think they're related to Meta. They were a classic one where I think they were working with Interglass before Interglass got bought by Meta. So I don't know all the ins and outs and players in that. But the important thing here is that there are some alternatives. Once again, this becomes more important now that you've taken, once you take a Lux XL on the table. However, and I told you this even before, because at that last show, if you go back, you'll know I was already skeptical about the mass volume production capability of the 3D printing process, that they needed something. These are, both this and AddOptics are kind of ways to get to kind of a mid-level customization. In other words, they're much more customizable than starting from scratch. Every lens is a new lens, and you got to build, because when you build an optics quality mold, you can spend $20,000, $30,000, $50,000 on that mold. It has to be extremely high quality, and they're made out of metal. And they're milled and they're polished and all that. So these are ways to get to this without having to go all the way to a metal mold. Because you can afford to do 400 different molds if you're building for billions of people. But it's a different game when we're talking the game world. Let's get into something. Now, this is something I asked about you, and they said they thought they saw you at the booth, but you told me that no, you had run afoul of HTC. So this is the HTC Vive XR Elite. Have you had any reports or whatnot? Or
A lot of VR people liked it actually. They thought it was good. Like they thought the mixed reality was better than the Quest Pro. I don't know if it sounds like you got to try that aspect.
yeah, that this is actually in the lower right corner. That's pass through. So
It looks a lot more clear
show it
from
to
first
me.
glance.
What's that?
I said it looks a lot more clear than the Quest Pros from first glance. I can read the Vive logo in the back there.
Yes. Yeah. Oh, definitely. It's not, I don't think, really meant for pass through. I haven't done the study of this, but it felt like the magnification wasn't 1-for-1.
Right.
So there's like in the Quest Pro, I could take it off and
Oh, the def correct, right?
it was designed. They definitely did things to
Mhm.
make sure that things appeared kind of correctly in the right place. Here, it was almost like it was almost like you're looking through a camera with a telephoto lens, looking through a camera where the lens wasn't the same as your eyes, so everything was at a different rate. Yeah, the image quality was much better.
Oh well, real quick, if you were to, I know you probably think both are like unusable, but like, what would you prefer, this method or the Quest Pro? Because Quest Pro is definitely more depth correct, but this is like more clear. It sounds like.
Yeah, this would probably be a little more useful. I think if I was going to try to pick up my drinking glass, I would rather have the Quest Pro.
Yeah.
If I wanted to see the buttons on my controller, it's a lot better. Because, as I say, that's the joke. Mm-hmm. That's really the joke, or really the way to describe it is you say, yes, you can see where the controller is with the Quest Pro. You just can't read the buttons on it,
right?
Or you can't see where the buttons are. So yeah, it's better. It's a better image, but neither one of these is really. This AR pass through is really more for. It's not a great image.
Mm-hmm.
It's kind of fadey and not a phenomenal image. Now that could be the lighting and everything else. These are actual through the lens images here. These top two. This is these are actually the same picture. Mm-hmm. All I did is I just took this and this is like the whole image, more or less the whole image of my camera. You can kind of see it cutting off just a little bit. So that's the whole image that you could see. And then this is the magnified. This is this, but magnified up. You can kind of see the grain or the stuff in it.
Yep.
So, but it's a good image. The demo was really hard to fix. It's almost too complicated. They had a Maestro demo you may have heard about. Mm-hmm. They gave one hand. Yeah, that's why I had this picture taken like this. This is actually me doing the pass through, but we did this. And the reason why I did like that is this is the way you do the demo. One hand, you have the controller, and one hand you did with your finger, and you would point. And that's the part I didn't get. I didn't know. I was wanting to push a button. I don't think you really needed to. It's kind of like you push with the controller, push with the thing. So one hand was doing the controller, and one hand was doing that. It's very simple. Try to lead the orchestra kind of thing.
And the one reason they wanted people to do that is because the Quest Pro does not support one hand, one controller right now. So they're trying to be like, hey, we got this. Meta 10 billion per year doesn't.
Yeah. I didn't realize that was why they're doing that.
Yep.
It works. It's really hard. One of the problems is you really don't want to be doing a game. You really would like to just be letting you play with it. Mm-hmm. Like if I was at home doing it, I'm not going to try to evaluate optics and displays and stuff playing a game because you're all busy. It basically totally puts your focus on, I got to hit this. I got to do that. I got to do. Yeah. I don't know if you've ever seen at Disneyland, Disney World too. I guess you've probably been to Disney World.
Quite a few.
What's the one with the Millennium Falcon?
Oh yeah.
You know how they got you pushing buttons and doing that?
Yeah.
I think almost everyone's reaction is it's not a lot of fun because you're spending all your time looking to push. You have you all the time looking at pushing buttons.
Yeah.
It's kind of the same thing. You lose the immersion. You lose that because you're too busy trying to do stuff to keep from having the people frown at you. They had frowny faces if you didn't do it right and stuff like that. They tried to mildly chide you to make sure you kept up with stuff. But the problem is you don't really get to see it. I will say they went all out. They had a real nice, this was at the
Win, right?
What's that?
The Win?
That was at the Win, and they had a big conference room and had this big fancy display on the outside that you went into. Once again, it was a good demo. I can't tell too much other than, it looked good. Image quality looked good. I mean, the Meta Quest Pro, when you use it as just a see-through headset, is pretty good. It's very similar optics. As I said, the pass-through is nothing to write home about. It's definitely not meant. I think that's the same thing. I always say with the Quest Pro, it was a kind of a feature for protection and for helping you find your controller and stuff. They got pressed into the wrong. It just got pressed into service, and it's just not ready for that.
The one thing I want to add,
something's right better than this one did from a pass-through mode, but I wouldn't use either of these as a pass-through device.
The one thing I want to add that I heard was this headset, unlike the Quest Pro, still has a depth sensor, hardware-based depth sensor inside, but it's not activated yet for the pass-through. So maybe some things will improve for the depth sort of thing we were talking about.
Yeah, I guess they could probably come up with a way to kind of rescale and redo this. I don't know.
Yeah.
I still think it's like I say, it would be good if it was scaled 1-to-1. I felt like it was kind of like it was a multiplier ratio. It'd be good if it was scaled kind of 1-to-1 with your vision so that everything lines up.
Right.
I still think all these things, none of these is meant to be passed through. It's not meant to be passed through other than in an environment where you just want to make sure you're not bumping into something, or you want to find your controller and not take the headset off to find your controllers and stuff. Okay. Now, since we're into AR world, I think, and I know you saw Lynx as well, right?
Yeah, this was my first time checking out this headset, finally.
Yeah, well, I've seen it a couple of times. I got in a running battle on Reddit with somebody who said, you need to talk with you because you said it was so sharp. And I said, nah.
I did think the image I was going in there thinking the image was going to be poor, honestly. And then when I tried it on, that was the first thing I said to Stan. He was the one giving me the demo. And I was like, for 1600 by 1600 per eye, to me it looked more, honestly.
Really? Because because I know the way the optics work and whatnot.
Right.
The resolution is really more like 1000 by 1000 or something. It's almost half of that because they've got to replicate the image in all four quadrants and piece it together optically. And somebody's trying to argue this was like a light field and do all this stuff, and I don't buy it. I've taken pictures of. I didn't get the best pictures this time, but I had pictures from the last time I saw it, and I've looked at them and I've looked at them close, and you can see where you also get right at those seams where the thing you've got to get your eye lined up. It's a little bit like the Fresnel lenses. You know how a Fresnel lens is so important. By the way, that's the biggest advantage, bar none. The number one advantage of the Quest Pro over Quest 2 is you don't have to line your eye up perfectly with the Fresnel lens. Almost, you do want to get it centered, but anywhere in the ballpark is good enough.
Yeah.
With these, you do got to get your eye right in the right spot because there's basically 4 lenses in there that are merged. And if you actually have something detailed, one of the problems you have, they're still using a very sparse content.
Yeah. One demo.
You've got to put up to really judge resolution. You got to put something up there with detail. Like put up my web page is duller than heck. I put up the dullest messages I can. And the reason why is when something's dull, you know when it's wrong. If I put up flat gray and it's got color in it, then you know it's wrong. You put up white, you got color in it, it's wrong. If I put up detail, like lines and stuff, and they're not there or they're blurred out or whatnot, they're wrong. In order to judge things with your eye for sharpness or detail or color, you have to put something up you understand what it really looks like.
I agree.
And hopefully you can look at it without even having to look at text stuff. Now, you going to your favorite baby there?
I was about to say, so this headset I use all the time. It's basically the same panel resolution. It uses like a dual element Fresnel lens. Yeah. And I think when I come use this all the time and I come to see what Lynx is doing, it looks more clear to me because I'm just so used to these lenses are not able to replicate that display quality as well.
Yeah,
So.
you may not. You may be sad to find out what the effective resolution of what you're looking at.
Yeah, exactly. Yep, 100%.
So I'm kind of used to seeing high resolution stuff, and I've been taking, and I try to take my subjectiveness out of it, but I also am when you look like this is the content. This was taken in the Ultra Leap. Ultra Leap does their hand tracking.
Yeah.
So this was taken in the Ultra. He was in the Ultra Leap booth. So this is a quickie I took of the show. It's not the best quality picture. Problem at the show at CES, when it's blowing and going, I almost gave up on taking through the lens pictures. You just can't do a good job of it. Normally, when I did the MetaQuest Pro, I spent over a month. I spent almost 2 months taking pictures. I've only done one of them yet. There's more to come. Hint, hint. A little foreshadowing. There's more good stuff to come, and they won't be the puff piece like I gave the first one.
Right.
Anyway, but there's Stan there. I think that one of the best things I told Stan this. I think one of the best things to happen to you is that the company Limback, getting back to people buying people, Limback getting bought. They got bought by Apple, right? This time. Yeah, it's hard to keep the players straight. It's either you kind of interchange the Apple and occasionally throw in Snap.
That's true.
But yeah, they got bought by Apple. I told him it's going to force you. They got rights. I know they have the right to make it forever and all that stuff because you get that signed in contract and all.
Yeah.
The realistic thing, 45 years in the industry says you're going to move away from that as fast as you can because you can't make the improvements you want. The guy who really understands it is gone, or he's working for Apple now, or he left the company and is doing something else. And maybe you can hire him on the side to help you out. Yeah, you can limp along that way. But I don't think this is the optics of the future. I don't think those were the optics of the future. It's you may have noticed when you put them on, it's way too fiddly this way. I mean, I spent a lot of time with the Quest Pro, and you can see the Pancake is in many ways, a much better way to go. At least at the time Stan was doing this, Pancakes were way too expensive. I don't know why. And that AddOptics company we mentioned a little ago, they say they can do Pancake optics lenses for not very much money. Well, if that's true, maybe that's a way out. So assuming somebody didn't buy them next, that's always a danger. The good news is the companies are laying off. The big companies are laying off now, and you heard the rumor that Apple may have stopped their optical AR development, which is we ought to do a whole show on that. That's an interesting story. But so they bought Limback, but that might have been one of their last purchase. I think that purchase went through about 6 months ago.
Yeah,
these are the kind of things you kind of. Once you know an event happened, you kind of look through internet history and look when things stop. And things stopped with him about 6 months ago. So my guess is that the Limback was the deal was done. Ink was done 6 months ago, and then it finally gets announced 6 months later. So anyway, so they did one thing that's good is I like the flip up. If you're gonna, but they're definitely doing a better job than anybody else. I mean, theirs is the best of the pass-throughs I've seen. If you were going to do, they are cognizant of making of the magnification, making things line up, doing that kind of thing. And they've got very airy, so the eyes show. You can see the eyes. There's good eye relief, so you can maybe wear glasses with. You can wear glasses with thing. Maybe you really had to push your eye in. I'm big on eye relief. That's a big mistake people make, particularly if you're doing anything that's going to be shareable. Like on a factory floor, you want a stack of these and you want a guy to come in. If you make guys do inserts and stuff like that, you just cut your market. You also meant like at a trade. A lot of these things you want to do it at a museum. One of the big uses of like a lot of these things is they want to put them in museums where you can see stuff that's not there at the museum to add a layer of stuff to it. Well, you can't sit there and say, oh, you got to send your prescription first.
Yeah.
They've got to fit over glasses. So there's something to be said for once you're into it, this is what I call an open helmet design. You've got a band going around your head. I like the bustle on the back. This is kind of my preferred setup. Once you realize you're not building glasses, then there's a lot to be said for letting them flip up and stay on your head. to say, I'm going to have to find some support here. I'm probably going to have to put a strap on it. And I'm going to put a bustle, and I put a bustle on the back, so the weight. And then what you should do is to move as much weight back there as you can. So that's a good design.
The one thing I want to add to agree with it, the one thing I like they did with their head strap design is the top strap. There's been a lot of companies, like even the Quest Pro. This thing for me and a lot of people I talk to who are used to VR is even with this like headband and stuff, it's just too much weight on the forehead. And Lynx has that like top strap going like this. And I think even with the way of Lynx headsets, that top strap is just a very valuable thing for comfort over time. It just distributes the weight a lot better as well.
Yeah, I'm forgetting on the Quest Pro, it has a strap of some kind, doesn't it?
No, it literally just has this head pad and then these two pads right here. That's it.
Okay, I was thinking there was an option to put a strap through it.
Nope. That's why I've complained a lot about it. A lot of people have. People are like getting like Velcro things. Maybe and like modding it.
Must be thinking of the Quest 2. That's right. I must be confabulating because I went back and forth with the Quest 2.
Yeah. Yeah, Quest 2 has the top strap. I'm trying to fix my focus.
Okay. So, while on the subject of it, I'm just going to give a plug. I've already done this, but we talked about, I figured this fit in with, so this is from my website. I did a blog article on the Meta Quest Pro. As I said, this is kind of my powder puff. I took it easy on him on this. Unbelievably bad. I mean, it just wasn't meant to do this, and you can kind of see how bad it is, and everything looks high resolution compared to this.
Yeah.
It's really, I think it was really pressed into service to do something it can't.
Yeah.
So here we go back, and this is from our last time we talked about this. As I said, here's a detail. See, here's what I said. You have to really look at not a see-through image. You really want to look at a virtual image. And in this, you can kind of see how the regions, and I've outlined them here. There's like a dark band. These are the seams. These here are seams and optics. And when you look at this in a high-resolution photograph, you can see how the resolution's going up and down and sideways.
Right.
So, and you can see it actually. You can actually see it in their stuff. They have a thing. You can actually see parts of it alias. That's the high resolution areas, and the parts that don't alias have been kind of low pass filtered by the lens. So, and it goes back to how they build the image. They basically have to replicate the image 4 times and then try to merge it together. But like I say, when you're doing pass through AR, it's going to look probably better than. I mean, their pass through AR is the best I've seen of doing that with a VR headset.
Yeah,
it was better. I would say it was better than the
Vive.
Than the Vive.
Yeah.
But it wasn't the same lighting, wasn't the same environment. You really got to get the things sitting there side by side and try them and stuff. So that's not a very fair comparison. Sometimes you can say something's absolutely bad or absolutely good, but it's really hard to get when something like which one's worse than the other. But their pass through is certainly is reasonably well done. But still, you're talking a camera. Camera does not have the dynamic range of the eye. Camera does not focus the way the eye does. The camera focuses at a distance. Your eye, as it looks around and whatever it's looking at, it's going to vary distance. Now, in theory, I guess you could, if you had varifocal, which they don't. These are all focused at about 2 meters. The world isn't all 2 meters away. So what you need to do is have the camera looking at your eye and refocusing and all, which is a whole nother ball of wax. So this one won't take long. This is Canon. You didn't get to see this.
No.
This is the Canon MREAL, not to be confused with N as in Nancy. This is M as in mother real. And I don't think they quite appreciated it. This is like a 2K by 2K per eye, 58 degree, basically 60 by 60 horizontal field of view. It requires a cord going all over the damn place. They give you a mile of cord. And I couldn't believe it, but I checked this like 3 times. $38,500 US.
I am so
It's
confused.
not sold in the US. It's only sold in Japan.
It's so confusing. I don't get it. Like, what? Who are they? Who's their market that they're trying to go for this?
Industrial. It's really for the demo is all industrial. This is a video. This is, by the way, I took a pass-through picture. This is a actual through the cam. This is taken with my taken with a Canon camera. And I have like $20,000 worth of Canon photographic equipment.
Right.
Okay? I have high-end Canon equipment. I'm not an anti-Canon person. This was really, I mean, I had somebody else said, I heard it was 15,000. So I looked it up. I couldn't believe it. They had a good demo. The demo room was good. You ran around. This room was a mixed reality demo. So you run around the room, and it was some movie that I hadn't heard of, but they'd taken the scenes from a movie. It was really high production value, the whole thing. You'd run around the room doing things, which are kind of, once again, you're so busy trying to play the game that it's really hard to concentrate on what's going on.
Yeah.
I think they had cord mining. I think part of these people's job was to do cord mining to keep you from killing yourself or running into things and all. I mean, it was a good demo. It's an impressive demo. I don't know what they hope to get out of this. I'm sorry. And they were really nice to me. I hate really giving a pan to people who are so nice to me and so helpful. But this is not what, and it's kind of a geeky, awkward, the way it comes down. It's a little bit hard to adjust. You see here, it clamps on the back of your head, and then this thing kind of comes down. It does flip up. It does have the flip up thing. But it's cord off the back and the whole thing.
This through the lens image here, it's like bending inward, like a weird.
Yeah.
What the heck? That's so weird.
Well, it's really what's happened is all your optics do that.
Yeah.
All your optics pin cushion, but normally you would optically cut it off. The only way to get rid of that, because my camera is going way out, my camera was taking a much wider field of view.
Right.
I was able to see, this has been cropped, but I was to see all the way out to this. Normally what people will do to make it look better is cut it. But what was happening is this was normally, like on most of your, because the field of view is so big and the stuff, normally what would happen is that would all get cut off by the lens. The lens couldn't go out this far. What you're actually doing, if like I said, if you go back, look at my pass-through demos, and I'm going to have other stuff coming up on my blog, you'll see the MetaQuest Pro does the same thing. The difference is that the display is not bigger than the lens.
Mm-hmm.
And here, the display is smaller than the lens can show. And so what you're doing is you're seeing that pin cushion effect. But I think all of the VR headsets have severe pin cushion distortion. If you look at the base image going out of a MetaQuest Pro, they barrel distort it. I've shown that, how the image barrel distorts. That's the correct for this. The problem is that this display is not putting out an image as big as the lens, so you're actually seeing the optics of the lens. Does that make sense? Yeah.
But you didn't see this in your eyes, right? That view, like, did it look like that in your eyes?
Yeah, you'd see that.
You did? Okay.
Yeah, this is my camera. I've got a 16 millimeter lens on a Canon R5. Okay, 45 megapixel camera. It's amazing how closely that resembles what your eye sees. It's very close to what your eye sees in terms of field of view and everything. I've really been pleased with this. I can only use it in VR. AR, I can't use it. Usually I can't fit the camera in. But I do use it. I use this, and I use for AR equipment, I normally use this Olympus camera because it's a lot smaller. The lenses are a lot smaller. I can cram it in there. But on this one, it's open enough. I could get my Canon camera, and felt appropriate in the Canon booth. So this was actually taken with a Canon camera.
I still just can't believe this thing exists. Like, my brain.
That was the reaction of everybody. And the few people I talked to at the show, they couldn't understand why Canon did this. I'm nothing against them. I really hate to say that. Most of the people, I really want them to succeed, but I couldn't figure out why in heck this was here. I think it's something they developed a few years ago. This is actually, I hate to tell you this, but I think this is their second or third generation.
I think so. Yeah.
So, yeah. This was actually just before the show. The guy flew in on me, but I thought I'd tell you about this. This guy's got a technology. It's called Panamorph, and they're really into building lenses. You know, I've heard of panoramic lenses, anamorphic lenses. They're actually into building these anamorphic lenses for projectors. But they, as a little side project, they realized that they could do something, maybe particularly for pancake optics. This is really kind of an interesting idea. You know how you talk about how all that power, you know, one of our people, and you've heard me say before that amateurs talk about battery life, pros talk about heat. Managing heat is the big problem. Like I think most of these newer pancake kings have fans in them. They have little fans behind the thing trying to cool the LEDs off, because those things are only letting maybe 10 or 15% of the light from the LEDs. LCDs themselves are very inefficient, and then they're only letting 10 to 15% of the light that gets out of the LCD to your eye. So you have to be generating extremely bright displays, like in the 1,000 nit range, to get 100 nits to your eye. And so what this guy does is kind of neat. Is he takes a mini LED array, and it's a little bit of a cross. I've seen the same concept done. This will work. I'm sure of it. Magic Leap did something. That's what I call source side control of light. There's a thing called Leia, which was with the red camera, that did something like this. You know, C-Real, it's a little bit related. The basic idea is what if each LED has a micro lens on it, and each of those lenses is collimating the light a lot, highly collimated, but sending it at a given angle. So now what you can look at is imagine that now you turn an array of LEDs into an array of spotlights that overlap a bit, but are each aimed in a different direction. And then if you track the eye, then you turn on the LEDs that correspond to where the eye is looking. So you can turn off the other LEDs. And because those LEDs are not contributing what your eye sees. And the point I make here, this is a picture I took of this is a Wave Optics one, snap. You always have to keep changing. I have to peel off, I have to put sticky tape on these things, keep changing the names on them. But this is the eye box. This is what happens inside of optics. If your eye is going to move around, you end up illuminating a very large area to allow your eye to move around. Now, this is somewhat extreme, but this is true of everything. When we talk about an eye box, that eye box has to be at least as big as your eye, as your eye can move. And then, but the only light that counts is the light that goes through the hole into your eye, the pupil. So what the idea of this is track your eye, and then combined with eye tracking to keep turning on sets of these LEDs to keep directing it towards the eye. And you can do this with a waveguide. You can actually see it with a wave. I did some experiments, posted. They don't have a great demo yet that I've seen. They showed me one little thing that was not overly impressive, but I was able to fill in the blanks based on my experience. And this kind of concept, I think, could be very important to pancake optics, because it not only does it help power, it also helps with contrast. If you think about it, because basically I have a rule. There's a rule of thumb in optics. Any light that enters, a percentage of that light is going to go someplace you don't want it to. So the best way to get better contrast is don't let the light in the first place. Because even though you may be looking in the wrong place, and the light from that LED, lights from LEDs are not supposed, you're looking over there, that black area way on the far side is still getting, because the light bounces around, there's going to be light making it to places it shouldn't do. So in theory, this concept should help both efficiency and should help image quality considerably, help contrast quite a bit, because you've eliminated a lot of light entering the optics. Some percentage of that will go where it shouldn't. So I mentioned this. This guy was actually going to fly to CES and said, "Hey, I'll fly down to the Dallas area since you're there." So I thought I'd include this because it kind of fits with all. I mean, everybody is talking pancake optics. It seems to be like everybody in your field is talking that. So I thought this was be interesting to your audience as well. One more that would hit into you. This is, I don't know if you saw these guys, VoxelSensors. This is kind of a neat thing. This gets back, once again, I tried to pick some things that would be interest to your audience. This is a private demo. They're supposed to have a video coming out. They keep telling me they will have one. This is their suite. Basically, what they're doing is they're taking a Lissajous pattern laser scanning, which is a lousy way to do displays. You remember time before I said the last thing you want to do is Lissajous scanning to do a display device.
Yeah.
But for this, it actually works pretty good, because if you look at it, the beam is kind of jumping all over the place. It's getting this corner, that corner, cutting out. If you're doing image recognition, you kind of want that, particularly if it's like cars or anything else. It's kind of like the big thing, you're going to hit lots of places. You'd like to hit it as fast as possible. So what they've got is a very special camera. So normally you think time of flight. Well, the problem with time of flight is your accuracy and distance is related to your ability to measure the speed of light. And the light travels a foot a nanosecond. So your accuracy is based on how accurate you can chop up a nanosecond. And you got to get a lot less than a nanosecond, because if you did 1 nanosecond granularity, you've now got 1 foot distance granularity. Well, what they're doing, and there's also things that use camera for triangulating, but the problem with that is it takes a ton of processing. Because you got an image there, and you got 2 cameras, you're trying to difference these 2 images, and that can be a ton of processing.
Yeah.
So the 2 ways that are commonly done are time of flight, and then the other one is 2 sensors. Well, what they're doing is they're adding a third modality here. They're scanning, and then they're able to actually capture at each point X, Y, and time. So they've got the big thing with this. They've got this novel new sensor that's not a time of flight camera per se, but it's similar to it. Simple without getting into all the details. So they've got a simple concept where they can capture X, Y, Z in time up to 100 megahertz. Okay. So now what they've got now is they can now combine triangulation with time and get much higher accuracy in their ability to know depth and distance and the whole thing. So that's what they're showing off. And they had a demo with this thing. They also had a thing on a turntable where they could rotate it around, and these would spin around while they do it. And then they would build up the image as they go. So they scan a Lissajous pattern out. So the idea is they can do it with a single one. They have some tricks they can do it with a single one. But for the best accuracy and the best of kind of all that, you'd like to have both. So anyway, I thought that would be interesting too, because they're kind of a semi-startup. I've known one of the guys who developed the software for this, the algorithm for this, but these guys have come up with the sensor. These guys are basically a startup semiconductor company that came up with the sensor, and then they're applying this algorithm that was developed for, I saw it when it was big equipment.
Yeah.
So they come up, this I believe is using that same scanner. Remember I talked about what was augmented? Remember augmented, I said they should stop wasting their time on building a display. Well, and I said they should focus on this. And I believe they're using an augmented Lissajous scanner for this, which makes total sense in this case, because you actually do this pseudo random is actually kind of goes from being an impossible problem in a display to an advantage when you're doing sensing. Here's one I know we both saw, because this is the one time I got to see you. That we didn't see. We saw ourselves here, and we never saw ourselves again.
I know.
This is. I jokingly call this the baby Maximus. You may see on my blog a thing on the Maximus. This is actually a totally different. They said it's quite a bit different design than the Maximus. It's much smaller, as you can maybe see. It's a much smaller engine, much smaller optics. Yet it still does 2K by 2K. It's 35 by 35, which is a 50-degree diagonal, which is pretty much kind of state of the art for see-through displays. It has image quality, it has very good image uniformity and quality. And this is a prototype still. This is their final thing with all their coatings. Yeah. This is a quick and dirty picture I took. Once again, even in their suite, it was hard to get a really good picture when you don't have time. Like when I did the Maximus shoot, I think I spent 3 hours to get those pictures. And I told you with the MetaQuest, I took 2 months. Because you keep going back and forth and whatnot. But there I am in the suite. The other thing that's really neat about it, And this gets back to Lux XL. One thing about me is since I get to see so much stuff and I've had 45 years in the industry, I start to piece things together. And one of the interesting things is there's no air gap required. One of the big claims to fame of Lux XL is they could print with an air gap. Now I've heard different stories of how true that was.
All right.
But in theory, waveguides need an air gap because if they need an air gap such that the TIR will be preserved. Well, if you get and I don't know how they're doing it, but I know with TIR, if you get the angle shallow enough, then the mismatch, what you actually need is not an air gap, but you need a mismatch of index of refraction. And whatever's going on, they say they do not need air gap. So you could actually dip this in plastic and it would still work. That's the first I've ever heard of a guy with a waveguide, a thin waveguide. Yeah. I do know that there's the former founder of the company. They did a company called Oorym, and I may have just a slide or two on them at some point. But Oorym has that same characteristic, but they're doing something quite different than this. So this is very different. Like the Maximus had to have an air gap. Mm-hmm. They were actually working with Lux XL. This new one does not need an air gap. So in theory, you could encase this, say, going back to one of the prior one. The AddOptics, you could do that. It's still a prototype, but anyway, kind of interesting. In a related field, DigiLens. DigiLens had the Argo, and I made their LinkedIn post. I got you get a lot of this too, don't you? Do you get the celebrity status thing where people are thinking
it's funny, it's hilarious.
I got a lot of that. I had a guy walk down the hall, and I think he was referring to he had just read my thing on MetaQuest Pro because he said, "Good job." I was busy on the phone with somebody, but he walked by and did that. This Argo is, and I believe he used to work for. I'm bad with names, but he used to work for ODG.
Okay.
So this thing looks a lot like ODG in a way, except the optics are all different. It's not a bird bath. This is obviously a DigiLens see-through. Now, the color uniformity is not the greatest in the world. It's a diffractive waveguide, but it does some good things. The forward projection, they've done a lot of work on this. I'm seeing this is a common theme. I'm seeing a lot of guys do this now. Now, it's not true. The Quest, the Magic Leap 2 has a lot of front projection still. Famously, the HoloLens has a lot of front projection. They're figuring out how to project the light downward. There's still front projection, but they're sending it in directions where it's much harder to see. So you see much less of it, and they're working on that problem. This is their head. So they're saying this is their industrial product, kind of aimed at the HoloLens 2 type of market. This thing has a little key, a little kind of thumbs or a screw you can put a coin in, and you can pop these backs off, and you can put a strap on it if you need to. Here's the thing with a headband strap. Interestingly, it has enough eye relief that they could wear glasses with it. Only this headset, and this is one of my themes of the conference, is that because of this big old nose bridge, they've got a lot of weight up here because they didn't put a bustle on the back. They've got a lot of weight up here. They've got to have this big old huge nose pad to land all that weight on your nose. They also kind of cheat a little bit because if you look at these things, they have these. Look how much that grabs around the back.
Yeah.
You're not fooling anybody. You're trying to grab onto the back of the head for grip. You're gripping on with dear life in the back. I just think you should give up. If you're not, these are not glasses. These are the biggest, ugliest. These don't really look like glasses.
Yeah.
What you should have done, and I told them this, what they should have done is given up, forget the glasses. You gave away your best feature, which is enough eye relief to wear glasses. Assume you're going to have a bustle on the back. You're going to have a strap on the back. Take as much weight, take every ounce out of here you can, and move it to the back and get the weight off the nose. That may mean you need a head. What do they call those things now? What are the thing pad they put on the front of that
like forehead pad or whatever, front pad.
Or you might need some straps. But this is we've given up on look. If give up on looks, give up on pretending that these are anything like glasses. Because if you actually, I don't have a real side view, but you can see there's a lot of eye relief here, which means these are sticking out. These are like glasses that are sticking way out on your face. Okay, a little bit like the MREAL and some of the other bird baths. Not quite as far, but they're still sticking out a bit. So why don't you give up on that? And then but the thing is, you got to move stuff out of the way also. Because if you may have junk up here that would hit into glasses. So you got to kind of carve out that area, move all that stuff to the back. So this was somewhat an object lesson. I said, you got a lot of things right in this, and they did from a design perspective. One thing that HoloLens has proven, because HoloLens, for the amount of money it cost and the time it was done, it's got the lousiest image quality I've ever seen. It adjusted for time period, it is absolutely horrible image quality. But what you should realize is the kind of markets that do this aren't after image quality. They're saying they want to draw an X, and they maybe need to see a red from a green X. They don't really need to see a photograph or whatnot. The other thing they did right here is they got a lot of stuff that's voice controlled. They put a big emphasis on voice control. So it's aimed at being hands-free. They've got SLAM. They've got all kinds of depth of tracking SLAM and whatnot. It's interesting, but as I said, it's almost like they fumbled on the 1 yard line. Like, you have all the technology here to do something pretty neat, or at least something a lot better. In theory, with a little bit of work and some industrial design and whatnot, you could make this better than HoloLens. But to me, they fumbled a little bit there. It's a modular design. They probably cranked this out pretty quick. They could probably redo it. So my advice, and I saw this several times, if you've got enough, it was like, well, we have enough eye relief to do with glasses. And I'm like, then why didn't you do it? Was kind of my reaction. So let's see what we got. Oops. Yeah, I think I've already hit all this stuff. Oh, it's also pretty bright. Got 3,000 nits. It's LCOS. This is another trend I've been saying. Everyone thinks I'm kind of an LCOS bigot because I used to work in LCOS. I worked in LCOS for about 10 years, but I haven't worked in LCOS for 11 or so. So I'm out of LCOS altogether, but I still get hit with that. But there's a reason why everyone's tending to move from DLP to LCOS. The people who had LCOS designs like DigiLens have moved there. I know Wave Optics was it shows their LCOS design. Then they basically said that, it's not keeping up in resolution and cost. And I had other people tell me the DLP costs have just gone out of sight. I hear they're raising prices and all. So what I'm seeing in the near eye space is people are moving to LCOS. Now, in your space, what I'm seeing is because of the pancake optics, there's a lot more interest in staying with LCDs. A little bigger LCD is okay, and pump the light through it. Just go brighter than heck with the lights behind it. We might see the OLEDs re-enter, but the OLEDs have got to get brighter because you're throwing away almost too much light. Plus, you have to polarize it. So on top of everything, the LCDs come out polarized. With the OLED, you're going to lose 60% of your light off the top, and then only get 10%. So you're really losing, you're getting less than 5% of the light out of an OLED that makes it to your eye, and that's just killer in that market. But anyway, so Argo was kind of interesting. As I said, I make a big point here. They should forget about all this stuff. And I've already hit all these, I think. Got time here. Here's Vuzix Ultralight. So that was the one that was getting all the buzz. Yeah. Okay, here's a comparison. The Vuzix Shield, this was a DLP, but it's full color. This is a color cube. So you got the color cube micro LED. So they've been playing with that too, but they weren't willing to show it. I didn't get the sense the image quality was real good. And then here's what's being used in those glasses. Now what I don't know is if this is the same micro LED or not. I don't know if they're using a smaller one or not. I didn't ask, and I haven't had a chance to check that. That's one reason I haven't written an article yet. But So what I got to try on, as you can see here, is the Vuzix Shield. They're also working on front projection. This is probably at a bad angle because I've got pictures with that's Paul Travers, the CEO. We had a little private meeting. This is a picture using their camera through it and all. Looks pretty good. By the way, this thing only has like 4 levels of gray. It's kind of hard to control the micro LEDs. So this only has like about 16 colors. So actually, if you looked at this picture blown up and everything, like I get to when I get home, you can see contour lines in it because it's only got 16 shades. So you have these contour map type things. Probably the fascinating thing, and I believe these are the ultralight engines in there. So one of the things they were trying to point out is they are making these things.
Right.
The whole reason for this being on display, this is on public display. This was on public display to show you that they're making them. These aren't just prototypes. They are cranking out engines. I don't know the resolution or the specs of it or how bright it is. I've got to go dig it out. They are, I always, as I said, one of my other show tricks is the things they don't tell you about, maybe the things they don't want to know. They don't want you to know. They know it's 38 grams, and I believe that it's 48 hours of battery life. That's what I know. So it's about like heavy glasses. These things fully loaded are like heavy glasses, and it's supposed to have 48 battery life in normal use. But I have a feeling that in normal use or typical use is, it wakes up occasionally. It's not on. It's not like you're leaving them on all the time. They're waking up.
Are these ultralight the consumer targeted ones that they're saying, or like?
Yeah, I think these are the ones more consumer. Although I think they could be industrial consumer. I.e., you got a guy at and Paul years ago told me about his classic thing is a UPS driver. You're at a place, you got the lenses. He says you got to be careful. These things still have to be rugged. Guys will at the end of the shift, they're going to throw their glasses around and stuff. Yeah. The idea is that these are the kind of things you might wear if you're picking up a package. The camera looks at it or whatever, and you decide what it is you do. It's an information plate. It's screen only. I don't think it's very high resolution. And by the way, that helps. This gets back to all these nasty physics problems, but the bigger you make a display, the harder it is to shove it through a small hole. And what I don't know is what happens is if these guys if you make a bigger display, the efficiency should go down considerably, like square law, I like.
Gotcha.
So if you make a display twice as big diagonally, you might get 1/4 of the light through it. That kind of problem. The efficiency just drops like a rock. And so that could be an issue. But anyway, it's dramatically small. Yeah, you finally are getting light glasses if you're willing to accept a single color. I got to wear the Vuzix Shields, which are, and I took this picture was taken at a prior show where I had more time. This is AWE. There's a lot less going on. AWE is a whole different thing. It's one event. Very few booths. You have some time. You can sit there for 20 minutes, taking one photo if you need to, which is kind of how these were taken. So this is taken through it. This I did quick hand and dirty, and it came out okay. But this is kind of what it's meant to do: is a moderately, medium amount of content. I believe there are 640 by 360. It's actually a 480 display nominally. But that's kind of what they display. I'm guessing this guy is smaller. I missed trying it. I think it was working on the floor. And I was thinking you get focused, as you know how this is, and you forget to do things when you're doing booth after booth after booth. So but anyway, that's the Vuzix Ultralight. They're making a statement here by putting a tray full of those engines. Each one of those, if you blow that up, is an engine. So, they're doing stuff. They're making a lot of progress in terms of doing this stuff. The question is, and they bought a company. By the way, speaking of buying companies, they bought a company. They bought a micro LED company out of France. I'm a little skeptical about it. I know that one of the founders of that company was the founder of Compound Photonics. But he was doing LCOS at the time.
Yeah.
And Compound Photonics, as far as I know, never made a product from design. They never took anything from design to production. And they were around for about 15 years before they were bought out by, which one bought them?
Compound was Snap, right?
What's that?
Compound, wait, no, that's Wave Optic. Wait, it was Snap, yeah. Snap, I think, right?
Snap bought them? Yeah.
I think Snap bought Wave Optics and Compound Photonics, if I remember correctly.
Right, because Plessy, who Compound Photonics was working with, was bought by Meta.
Yep, that's what it was.
You have to have as they say, you can't tell the players without a scorecard. So, yeah, that's the way it goes. Ant Reality was there. We talked about them last time. They had a well-attended booth. One thing I do want to correct from our last video show.
Yeah.
They are on axis. They said this actually is on axis. I thought it was slightly off axis. Turns out it is on axis. So I was wrong on that. But there is a variation in focus across the field. So I don't know what's causing that. Maybe it's the whole thing. But and they were there. They said it's better than it was before. They worked to get rid of the seam. It's a little bit like we talked about with Lynx. You got to get that seam perfect. That seam's right on your eye. It works pretty darn good. Works better than you would think. But once again, it's very similar to a bird bath. You can see how dark it is in and around my eye. You're blocking probably 70%, 80% of the light's getting blocked because, when you see through it. So, but they had a very, I emphasize, see that line there? One time, something I want to take a booth, I make sure, try to capture the atmosphere a bit. And they had a big line.
This one coming from this booth actually was one of those booths that the VR people, they were all over it. They thought the 120-degree blackout everything was just incredible.
By the way, I hear this wasn't actually 120. I heard it was 100. 120 is what they're capable of doing.
Yeah.
I think their next step, that's what I've heard. I don't know if that's really true. I think 120 is their goal, but I think this thing's 100.
Funny thing I noticed about they had every single optic on display basically, and the first two, I think there maybe was 4 optics, and the first 3 were all moving pictures and videos and stuff, show off the OLED, and then when you finally got to the 120-degree one, that was just like a static image. So I wonder if there's some issues with driving to make it.
Yeah, it could be a computational thing. By the way, you'll notice they follow my blog. That's my test pattern that they've done. So, and you notice so did Lumus. My task patterns get around. You can tell who's watching the blog. I talked about Lumus and Oorym. Oorym's a little startup. Founder was one of the founders of Lumus. It's a small shop. They were also showing a heads-up display. To me, they hadn't made a lot of progress in their optics. This is actually an older one. I'm not able to get really good pictures through the optics in a quick demo.
Yeah.
But they're still working on stuff. One thing neat about them is they're orders of magnitude more efficient than waveguides. So they might be a good coupler to a micro LED or whatnot. The head of that thing is really impressive, but they're a small company and they're making slow progress. So I don't have a whole lot more new other than they are trying to do a HUD, but I haven't quite figured out why. They've got a big frame around it because it's actually a fairly complicated set of optics. And when you get at the wrong angle, you can see things. And also you see it's kind of capturing overhead lights and stuff. I don't know. No time, once again, on a show floor running through booths to know all the ins and outs of it. But they're an interesting company, partly because the optics guy is a real optics genius, and it's got some really high efficiency potential. This is a booth. This is in the Japan area. This is Cellid, and this is another one, a little bit like the MREAL from Canon. Why did you come to the show? Everybody's comment was, this is an actual view through it. It's not a totally, once again, it's a quick grab and all, but this thing's aimed wrong. You can't get your eye very close because whatever their projection engine was, you're looking at it. This is the eye in direction. So you can't get your eye very close because this is in your way. I couldn't get my camera really in real close because the thing's in the way.
Yeah.
I couldn't get my eye there either. So it's a pretty fair shot. I mean, you see, it's a diffractive waveguide, really bad color rainbow effects.
Really bad.
Captured light from all over here, there, and yon. And it's too low. It's not where it's supposed to be. It's it's supposed to be, the image is supposed to be up here.
What the heck?
So I don't know why they bothered. They were in the Japan pavilion over at the thing. I had heard of them. I knew of them. They had two booth people there who couldn't really explain anything, so I didn't get to talk to anybody. So it's not a totally fair thing, other than it's it's not ready for show floor. It shouldn't have been on the floor, in my opinion. They should have maybe in a booth or say what they're going to do, or have people there who could explain why it's so bad and that we're doing this stuff. I heard somebody say they were going to move it up. This needs a lot more than moving up. This looks like stuff I saw 10, 15 years ago. It's not ready for prime time. Real quickly, I may have talked about them before. They're there with their 4K LCOS. LCOS is moving on. They also had a phase. One thing you can do with LCOS, you can hit it with laser light and do phase illuminated.
Yeah.
And you can actually project images. One of the problems you have, though, is that you get orders. So some of the light goes to the image and some of the light goes to out of match them. You guys see the same image here and the same image down there. People are looking at using phased LCOS for doing holograms. You can do this is real hologram stuff.
Yeah.
So you tend to use phase for doing holograms. They also were showing a near eye display with their 4K by 4Ks. This is basically a bird bath. It works. It wasn't tuned up well. They just got it out. They didn't want, and for good reason. They didn't want pictures of it. It wasn't ready. But they wanted to show you the device was working.
What's the benefit? I guess their benefit is it would be a brighter image for a bird bath compared to the OLED. Is that their one thing?
This is LCOS.
Yeah, that's what I mean.
It's gonna be.
Yeah.
It's gonna be gangbusters brighter.
Yeah.
You can go any brightness you want. You could go thousands. You can off an LCOS with the right optics. You can get into a waveguide when you collimate the LED. You're talking millions of nits going into the waveguide. So you can blind a guy if you wanted to with LCOS into the bird bath. But yeah, that's the reason. I don't know if that's the best use for it. You could also consider particularly when you're talking a 4K by 4K, you could start thinking about marrying this up with pancake optics. Now you got to figure out how to get the light in and out. That's your next problem, because the problem you have is that these things require a beam splitter of some kind. But there may be some way to optically put that into a bird bath. There are ways you could use a waveguide to illuminate the LCOS. There's a company called Hymax that does that. So you can bring the light in if you can make this thin enough, and then put pancake optics on top of it.
Right.
So there may be some ways to go there. It's a little hard. I've seen them a couple of times. They're friendly people. They're out of Korea. The other company out of Korea that does LCOS is a company called Rantec. Rantec's being used. I've seen them in some headsets. So Rantec, these guys apparently are a complete assembly shop, whereas Rantec is what we call a fabless. They just make the design. The LCOS itself is applied by somebody else. May says that they have the whole end to end. They build everything all the way. They put the stuff together. So, but I didn't see anything remarkably out of them. I haven't seen a remarkable headset with it. One thing they did have, I didn't show here. They had headsets using theirs that look like VR headsets with a motion platform and all. So I don't know. I didn't get a chance to try that, but it's interesting. They're one of the guys doing LCOS. I think LCOS is going to stick around for a while because honestly, micro LEDs, even with all the progress Parotech making, I still say it's probably a 5-year out. If all goes well, technology. You got to get color. You got to start showing me how do you do color and how do you yield it and whatnot. I think one of the biggest breakthroughs could be if you could do that pixel shifting. That could really help, because all of a sudden you take your yield problem and solve it. You could basically you could go from being, this is one of the problems you have with micro LEDs now in watches. You realize the watch is 1/10 the area of basically 1/10 the pixels of a cell phone. If you kind of look at them, about 1/10 the pixels.
Yeah. All
right. Well, if you can get 90% yield on a watch, you have a product. But if you take 90 to 0.9 to the 10th power, you are bankrupt. That is the product.
Yeah.
And so before we see LEDs in cell phones, we're going to see them in watches. Unfortunately, In a headset, we could probably vibrate it. I don't know. Maybe on a watch you could vibrate it. The other problem is the pixels are so much bigger. Like direct view pixels are typically in the order of 30 to 50 microns. Depends upon what you're doing and how, they're bagging rights and all this stuff. But 30 to 50 microns is typically a cell phone direct view display pixel.
Yeah.
These guys are talking 3 micron pixels, or 1/10 the size and 1/100th the area. So we're literally talking an order of magnitude linearly in 2 orders of magnitude in size smaller to do these. So what happens here is, in the case of these kind of micro displays, your problem is how do I make it bigger?
Yeah.
In the case of big display, like big panels, you're almost trying to make them smaller. That's why the pixels are so big and chunky, because there's not much you can do to make them smaller without going to really complicated optics. Here, you need complicated optics to make them bigger. That's where pancakes come in, because you can do some things. Pancakes can be optical. You can get some more optical power without going crazy,
right?
The way you might have in a straight path with Fresnel lenses and stuff. So anyway, but we'll see. But you might see these come out in something like with pancakes, if you can figure out how to illuminate it. You might even look at doing something crazy, or not crazy, but that panamorphic thing. You can imagine combining that with this and getting some really high efficiency. This is polarized, so it's already set up in that regard to go with pancake optics.
I think the one thing that's like weird for VR is every display in VR is usually square rather than the widescreen.
Well, the beauty of LCOS, it's cheap. Yeah. This is another big advantage LCOS has always had over DLP. DLP, every design is a major engineering effort. You could spend I could take a 4K by, I think there are 2K by 2Ks out there. I don't know if I had their whole thing, but a lot of people are doing 2K by 2K already.
Yeah.
And if you got 4K, if you can make them square. I can cut these anyway. With LCOS, it is so much easier than almost any other technology to change the shape.
Right.
It's really that's generally a fairly easy job. So if they got they can get there.
Gotcha.
That's not a problem. Real quick, I'm actually almost done if we got time.
Yeah. Let's finish it up. It's fine.
Yeah. All right. This is actually a Vuzix in disguise. I'm now into what I'll call startup corner. I moved a few startups up there like that. But this is the company. This is actually, I believe, the Vuzix Blade. And what they've done is they've taken a Vuzix Blade, the optics from it, and combined it with infrared cameras. And so what you're seeing is you're basically now turned your vision into infrared vision. So it's an interesting use. And the idea, it's a company called ThermalGlass, or like I said, this is startup corner. So, and you can tell, by the way, this is the view of the casino you can tell where we were. You've probably been there.
Yeah.
That's the Grand Lux at the Venetian that we're in breakfast at, I think. So, but basically it does let you see, you're looking forward and you see a thermal image of it. So it's kind of a neat thing. Now you see, once again, it's diffractive optics. Overhead lights get caught.
Yeah.
This is what we see with diffractive optics all the time. But anyway, this is an interesting product. And like you say, in this particular example, they're adapting a Vuzix. They looked at other technologies, other optics. Frankly, Vuzix was easier to work with for them. I think that was one of the, part of it is, part of it's showing up. One of the things I try to remind people, because all these people are so mean to startups. I mean, they won't give them the time of day. You're doing something new. I always like to remind them of Wozniak. You know why they chose the 6502 for the Apple II? It's the only thing they could afford. It was the cheapest CPU available.
Yeah.
Ironically, or interestingly enough, the IBM PC also used the 6502. It was a keyboard scanner in the IBM PC.
That's funny. Wow.
Yeah. And actually, a lot of initially, until they did some faster versions of 6502, but actually what made the Apple was expansion slots, something Steve Jobs did not want. Wozniak fought for the expansion slots. And that actually what saved the Apple II in some ways, because they could add in, they put a Z80, which was a much more powerful processor, still nothing by today's standards, but it was an 8-bit CPU, much more powerful than the 6502. And effectively, then they were using on the 6502 as a keyboard scanner and using the Z80 to do it. There was what's the language? CPM? Not CPM. Anyway, they had an operating system they ran on it that operating system and leads to Microsoft, because they did a version of that Digital Research, I think it was a company. Anyway, their operating system, they had their disk operating system for that. Ended up getting my company in Seattle copied it, and that was the one that Microsoft bought. And everything in this world ties together in one way if you know enough history. But anyway, this is Startup Corner, and so they got a working thing. This is a first pass product and all, or first pass prototype. But it's kind of interesting, and I was at the floor. That was one of my breakfast meetings. This was breakfast on, I want to say the 4th day. This is probably the last day of the show.
Okay.
And then I'm going to close with Tilt 5. I had dinner with Jerry on her way to the airport. They just won a Popular Mechanics Best of CES award, and she was actually a little late. We were a little late hooking up for dinner because of that, because she was having to accept the award and they were doing photos or I don't know what else. But this is one of the ones I've got. Mine is, I'm supposed to be getting mine soon. I think they're gonna. I think Jerry was gonna pack a few extra goodies in for me. So I've got one coming. One that I bought. I bought it, but I think they're going to be a little bit of free stuff to go with. So I'm hoping to review that later this year and really go through it. But she's shipping product, making money, and trying to raise money. It's really sad when you look at, I look at the Mojo Visions of the world, and they're making, Mojo Vision raised $204 million, and to me, it was one step above a scam.
Yeah,
that people have put 400, put 200, and then whereas Jerry, she's put her blood, sweat, and tears in this for around 10 years. It's, she could really use, where money would really propel this product. I think everybody who sees it goes, oh, wow. They're all impressed by it. Every time she demos it, she gets people impressed by it. And almost sadly, it's probably like 5 years old. I mean, this is really the thing she did 5 years ago that it took that long, just like that other guy, the guy before, 5 years to get to a product. That's what it is when you don't have big money behind, when you don't have money behind you. I mean, real product development should take maybe 2 years,
right,
from kind of concept there. Because the first year to get your prototype and get that all working, and then another year to get it in production. But if you don't have any money, you're doing everything slow. Everything's on the slow boat. You're waiting to get approval. You're waiting to get the money together to do this and raise and whatnot. I honestly, I said, I said all the VCs in Silicon Valley should be absolutely embarrassed.
Yeah. Oh, yeah.
That the way she's had to struggle. I've heard stories about people, she knows one big name guy, his wife didn't want him to invest. It's like, it's amazing they can't roll off. I mean, I don't have that kind of money. I'd give it to her. But that they can't roll off a few bills and get her really propelled a bit.
Yeah, it's ridiculous.
I just can't believe a product has so much good press. They get so much wow at the shows. They win all these awards, and they're struggling they're basically trying to raise money so they can ship product at a profit. If you go back to all the stories these VC tell, now I don't know, Jerry's a bit of her own creature. I like it. I mean, I'm amazed. I don't know exactly how old she is, but at her age, she still has that startup energy. That I mean, she talks stuff like she's a 20-year-old still.
Yeah.
Okay. I mean, she has that kind of energy. I don't understand. Now, they give the money to the fakes. They give the money to the Theranoses and that kind of stuff. They got lots of money to give to those kind of scam artists who wear the turtleneck T-shirt and the deep voice and all that crap. But somehow they can't roll off a few million to get her really up and rolling and going.
Yeah.
So that's my little plug for there. I don't know if she wants me to do it, but I told her almost an amazing. the disconnect between it. It's like the VCs wanted CEO who's dishonest.
Yeah.
They will give more money to a dishonest CEO. And I did hear this theory that says that all CEOs have to have a little disconnect with reality, because they really knew reality, they'd probably give up. But you know, that you have to be a little disconnected from reality to be a CEO. And they expect, as the guy told me, and this was a lawyer talking behind the scenes kind of stuff, but he said they can't be dishonest about the wrong things. For example, if they get money for something, they need to spend the money on that. They can't go spending it on wine, women, booze, and whatnot. They've got to take the money and earnestly spend it. But provided they earnestly spend the money on trying to make the product, they're okay. And you expect them to exaggerate. But like the physics was never going to, that Mojo Vision, $204 million was never going to work. And yet this is actually working, shipping. According to her, they actually ship it at a profit per unit. That's amazing to me.
Own dev kit for developers to actually build on their platform and everything. It's like so much work they've done. It's crazy. It's absolutely crazy.
Yeah. And they could reduce the cost of this phenomenally. They can improve the quality phenomenally. A little money, some money in this thing could make this thing really a lot better than it is. I look at it and I know what technology's in it. They're using really old, not the best. This is LCOS. It's a really old LCOS. I mean, it's like a 10-year-old LCOS chip.
Yeah.
This thing with modern technology and a little money to make it go, you know, that's my plug for it. So that's why I threw this in here. I did meet her for dinner, kind of on our way to the airport. I don't understand it. I get energy off. I mean, I like working with young kids. I'm 68. I like working with young people because they give you energy. Right. Mm-hmm. They got that verb and it gets you up there. She's amazing at I don't know what her age is. She can't be that much. She's younger than me, but not by, not half my age. And she's got the energy of a 20-year-old. So I really root for her and I hope it goes.
Same.
Like I said, I spent my own money to buy one after seeing it. I'm more curious about, I'm not really a big game player, but it's good. It works, and you can see through the it's pass through AR and all, but got gameplay in it.
Yeah.
It works. It works better than most I've seen, and it could be cost reduced a ton. It could be improved in quality a ton. It could do both. You could have better quality and lower cost if they just put some money in it. Yeah. Anyway, I think that's my last one. I don't know what else.
No, I think you covered everything perfectly. I mean,
anything you saw that you really liked, or
it would probably give me a whole other hour if I had to talk everything. I will spend one thing just to finish it off. And my favorite thing at the show, and I think I've already told you, was the Varjo XR3 was really just like it was one of those wow. Like I don't get wow moments in VR anymore. I'm really like used to it. But I was quite impressed with the VR.
It's the
and
one
the
that
MR.
had the center, foveated center.
It does, and I know they when they first were talking about, they were talking about moving it, but really, like, I don't even.
Well, I think I've got theories that say that moving it's not a little hard.
Yeah.
That moving it may not be possible.
Yeah.
I'm not convinced. There was a company called iWay that was working on doing that. And I said, if you can prove that you can move it, just move the center image. If you can move that center image and my eye not know, you've got something. And that's all you got to prove.
Yeah.
And they went bankrupt right after that. But they were still doing a static foveated. I don't think people realize it's not like twice or 10. It may be thousands times harder to move it. Because you've got to remember, your eye is moving too. So you don't know when that image is moving. But I think one thing they did as a startup is I think they kind of flipped. They did the pivot where they realized they weren't in the foveated display business or the foveated VR. They were in the high resolution VR. Because what's going to happen to them? What's going to happen to that is that's going to go away. Eventually, you're going to get a display. And they're kind of seeing that with their so-called consumer-ish version, their lower cost one. Is it Aero or whatever? They're going with a much higher resolution display. And that's the direct. I think in the case of VR, that's what you do. You just eventually you get the display that it's high enough resolution. You don't need the foveation.
Right.
You're just better off to put the money to display and go. And you realize you're not trying to do. I mean, their pass through and some of their stuff works pretty good too. I mean, you do feel it there. So they're basically in the high end, the super high end of VR, as opposed to trying. Although I think they got that toe in, they're kind of going back, but they're basically using higher resolution. I think the Arrow, it's a higher resolution display.
It's like 2880 by 2880 per eye. So
it's not. It's okay. So it's 2K by 2K. I mean, you can see where what you would do next is you might go with a 4K. I mean, there are micro LEDs that are 4K, so you can imagine taking a 4K by 4K and putting that into pancake optics or something, and you're you're approaching home.
Yeah,
you're approaching something that will rival what they're doing.
Yeah.
So I think they were right to pivot, and what they realized too with the center foveation. You can also, the other way to go is to make that center spot bigger. As you make that bigger, you get more. The eye tends to stay within 30 degrees. So if you can get about 30 degrees, you've really got the sweet spot of where you look. And so what you do is you could make that bigger, but I think the other way to go is you just go with a 4K or eventually they say you need 8K by 8K. That's probably a bit of exaggeration. You don't necessarily need 60 pixels per degree. I've always said diminishing returns hits at 40. Until you get to 40, and once again, MetaQuest Pro is only 20 pixels per degree. It's pretty dang chunky. You can see with your own eyes the screen door. Once you get to 40, you're getting close. You're getting good enough to do text. That's the other thing that was stupid about that, and I haven't gotten into it on my blog, is that you're not doing business work on 20 pixels per degree. None of these guys. Nobody's doing spreadsheets, word processing, reading the newspaper at 20 pixels per degree. The fonts have to get blown up so big that your eyes have to move so much. It ain't happening. But once you get to 40 pixels per degree, that's actually, if you did most people and actually did the math and looked at their monitor and where they're sitting and all, people are sitting at about 40 pixels per degree. That's all they really can see on their monitor. That's getting to where you're pretty good. 60 is like you're really fine tuning it. You might get a little more crispness to, you're getting beyond just functional and getting more into perception. It feels a little realer. It feels a little crisper. You can't know why. Whereas the difference between 20 and 40, you know why. You can see the pixels and all. So but that's good. I didn't see him this time. I saw him at AWE. I'd seen him CES. The last CES that was held in that was the full up show in Vegas before pre-pandemic. So I didn't put a priority on seeing that again. Plus, you're really more the VR guy. I only went to HTC because you couldn't. I thought that, and because it was doing pass through. If you look at me, look at where I hit the VR was where they were doing some level of pass through. That's where we kind of.
It is funny how everything's cross-roading for sure. But
if there's anything else, if you want to follow up with more of your impressions, or if you want me on that, I'm fine. Or if you not, that's fine too. I'm happy anytime you come up with a new technology. I'm happy to dissuade you of why it's the world's greatest miracle. That's kind of my job in the industry right now is to pop balloons. But okay, with that, I'll let you get going. I'm going to dinner.
All right. Thank you so much for coming on, explaining all this AR stuff to us VR nerds here.
Hopefully, I know I was a bit long-winded, but hopefully it was fun.
It's very educational.
It was good to see you in person at CES. It totally changed my perception of you. I see. You look smaller on television. That's all I can say. That's all everyone said.
Yeah. No, it was fun. This was good. And I think it was also fun to have you on because, I mean, last time I had you on, there were still people very hopeful that we're going to see this consumer immersive AR. But we did this right on the wake of the Apple optical AR project basically being canned for
Yeah, we don't know for sure, but that guy, I told you this. I think if you roll back to our thing, I actually cited it in my article when we think they've canned it. Now, I've heard all kinds of different theories on this. One is it's a misdirection for Meta, so you can't be sure. I think what we'll want to look for is LinkedIn. The classic way to look for it is you start looking for LinkedIn. People start doing searches on LinkedIn for people who are changing jobs. If they're changing jobs, if everybody who was working on that project starts changing jobs and moving to other companies, then you kind of know that the thing was canceled. So we don't have the exact confirmation because it's the same people as telling us it was going to happen.
Right.
And as I put in my article on it, one of the business analysts told me that you got to realize that they're feeding that you think a company like the big as Apple with $1 trillion market cap Apple doesn't know who's leaking to these people.
They
don't have they don't have investigators tracking these guys and knowing what's going on. Anybody who's sharing with them is taking a big chance of getting fired or is doing it with the blessing of the company for some reason.
Right.
These guys are not, apparently, I think Apple knows where these guys eat. Okay. They know where they go. They know what they look like. It's very hard to funnel stuff out of Apple. And I'm sure the guys in China, maybe they can get enough money for a leak that they can withstand the getting fired. But so some leaks come out. So we don't know. I can't be 100% sure. But as I told you last time, my speculation was the problem I have, and we really should do a whole show on this. But my thing is, and this is the part as I put, I think in my article. Wait, what? That's the whole reason to be doing this stuff. It's like Meta. I think if you told Zuckerberg that optical AR is impossible, it will never happen, I think he'd be looking to get out of VR. I don't think VR. I believe VR and the pass through and all that is seen as a stepping stone. And I told you this last time. I think is I'm consistent. I haven't changed my opinion on this yet. That Zuckerberg's a true believer in pass through in AR and optical AR and all that. That the whole VR thing that's because of what we can do now, but it's to work towards this HoloLens. I think in the case of Apple, it's somewhat the same. That they're kind of like chasing behind, saying, "Well, if this AR, if Zuckerberg's putting the big bucks in this, we better put some big bucks in and make sure we've covered the bat, as I call it, that we've covered it just in case it happens, that we're in a better position than them if it does happen." And so that they've got to do it. But if you're just doing pass-through AR and doing it with VR, does Apple really want to does that market big enough for Apple? That's a big market to a little company. It's even a big market to a medium-sized company.
Right.
That VR market is not a big market to Apple. And they're going to do a $3,000 initial headset. The rumor is $3,000 initial followed up with a $1,500 one. Well, $1,500 one, everyone's barking about being too expensive with the Meta Quest Pro. It ought to do more, but we're talking 2 years from now.
Yeah.
I don't know if that's Apple really wants to get in the dirt on the margins and all. And the problem is with I call it a four corner. Disney used to talk about having a four corner product. The best product is one that appeals to, where you get to everybody, where everybody uses it, like a cell phone. You've got to hit children, teens, adults, and seniors. If you got a product that does that, like a cell phone, a smartphone does, that's how you get to billions of units.
Yeah.
That's how you get to Apple iPhone numbers, is because everybody's using a phone, and from young children all the way to people up until they die are using those products. But yeah, I think Apple, I don't understand, to wrap that all up, I just don't, it seems like the whole reason for Apple to even be messing with VR is as a stepping stone to AR, and you've taken the reason away. So I wonder what will happen with that whole program. Will they put it out there? Is Apple going to really want to, do they really want a failure? What was that? Was it a Spider-Man movie or something that they pulled, or a Spider Lady or something? There was some movie that was so bad that the studio pulled it. I wonder, will Apple really go out there with a $3,000 AR headset? Oh, well, we can go on forever. Maybe we should do this. We should do these more often and probably with a little less time, and a little shorter and less time.
Oh yeah, yep.
Take care.
Bye.
Bye.